Hello. Hi. Good day, everyone. Um, just a quick check, able everyone. Yeah. Okay. Thanks for the response. Yeah. Thanks for a good day to everyone, and thanks for joining us with these sessions or to talk about this topic. Yeah, DevOps that helping you through the skill through the continuous deployment. So first of all, I would like to really thanks to the IO Foundations for giving this opportunity for Red Hat to present on this topic. And just a quick introduction to myself. I'm Ming Fei. I'm the solutions architect in Red Hat Malaysia, helping on the some of the technical enablement activity such as like container, DevOps, and operation and so on. Yeah. Today, suppose we have two speakers, but my colleague, Mr. Karthik, unfortunately, he's not feeling well, and he'll be absent for these sessions. But no worries. I think there'll be more series coming in the next IO Foundations activity, and Karthik will be eventually presenting on different topics. Yeah. Yep. Okay. So just a quick uh, agenda that we want to cover for our topic today. What is basically we want to discover what is a CICD. If those are some of the some of the audience here is not knowing what is a CICD, we'll discuss some of these what is a CICD about, and then after we talk about the CICD, perhaps we want to zoom down to the cloud native CICD, which is a different variants of CICD, whereby it's having a nature of like the serverless and containerized and etc. And then we will going through some of the two discussions. I mean, two so-called introductions. Basically, that will be a Tecton, which is our Hat Openshift Partners upstream project, and then we also have this tool called ArgoCD, which is OpenShift GitOps in our Red Hat product suite. So all these once it's done with all the information description, some of this summary, then we'll go by the demo to use this Tecton and ArgoCD in our CI/CD development. Yeah. Okay. So to start with, right, I think this topic about CI/CD, evolution of software development methodology. When we talk about CI/CD, it's important for us to understand the evolutions of software development and how we got into the DevOps in terms of the application delivery methodology. First, right, we have the waterfall methodology where it emphasize on the linear approach in deliver the apps requirements often defined before the coding in the linear or the waterfall approach is very much silo between the team during the development because of this linear approach, and there's no cooperations or collaborations between during the different stage of development. Waterfall actually works well, except that the degree of the time of months to year perhaps is really not acceptable in today's hyper competitive world. So this bring us to this agile approach to deliver software. Agile applications development is actually about the iterative approach in deliver and application solutions. So it involves actually the cross-functional team and often prioritize on the user requirement and deliver the app's functionality iteratively. And due to all this, right, the earlier feedback and shift to the left testing, so it makes possible for a faster release time for your application development. So delivery or software sprint of days to weeks was a big improvement as compared to the waterfall methodology. However, this is still not fast enough to keep up with the even more competitive world and the some of these elite performance of those who always like to challenge the current way of doing things in a better way. So that's how the DevOps was born, where its main focus is on collaborations and cultural change between the collaboration and cultural change between the team, as well as the key concept of this called automated the delivery of process that we are talking about, deliver a software in hours or even a day or daytime instead of talking about the weeks or the months. So and this actually DevOps is a complementary with the agile software methodology that we normally the software team define. So from Wikipedia, right, the definitions of the DevOps is actually a set of the practice that combines software development and the IT operations. Yep, there is two main entity that we're talking about, which is the development and the operation team. Therefore, the words of this DevOps. So it aims actually to shorten the development, software development life cycle and provide a continuous delivery with high software quality. Okay. CICD. CICD is one of the prominent practice and a key DevOps principle that focus on frequent deliver the apps to customer by introduce automation. The keyword is automations into the app's development. The main concept attributing to the CICD are the continuous integrations, continuous delivery. CICD actually introduced the ongoing automations throughout the lifecycle applications, from the integrations to the testing, to the delivery, or even to the deployment stage. Taking together, these connected tasks actually we often refer as a CI/CD pipeline. To be specific, continuous integrations, of course, CI is an automation process for developer. A successful CI often means a new code that's changed to an apps are regularly built, tested, merged, and released to the shared repository. Whereby continuous delivery actually refers to the automating the release of these changes to a stage or the pre-production environment, oftenly, which can be then also come with in place with all these approval process by the operation team or the release management before it's getting into the productions. The purpose of the continuous delivery is actually to ensure it takes minimum effort to deploy a new code to the environment. So CI and CD. So these are some of the examples of famous tools that are used by many organizations or the enterprise when they are building their CI/CD process or the system. For example, Git is often used for the source code version control, where it allows a multiple developer to check in and merge their working code and share and to the shared main line of the code that takes for later for compilations and subsequent deployment. And then Jenkins or TeamCity or Ansible, that's all are the these are all the famous CI/CD automations tools that are available in the market. And testing tools such as JMeter often used for unit testing as part of the CI/CD pipeline, and then SonarQube for the code quality scanning and etc. And JFrog Artifactory or Nexus is normally used for as a repository manager for the repository purposes. So these are some of the common tools in the market for building a CI/CD process. So that is about some of the information on, some of the information about CI/CD. So what is the cloud native CI/CD, which is the main topic we want to discuss today? When we talk about cloud native CI/CD, right, often it refers to the three main principles. The first, we talk about container. Actually, cloud native CI/CD is really meant for container. They are built for the containerized apps and the environment and runs on the Kubernetes. That's the first principle when you talk about the cloud native CI/CD. The second is the serverless. Serverless is that meaning that they can run, this cloud native CI/CD can run and scale on demand without the need of the central CI engine to be maintained and taken care. Take an example. When a CI/CD pipeline is run, the resources will be allocated for the process, and as soon as the CI/CD process is completed, the resources will be released back to the server. This is what some of the characteristics of the cloud native CI/CD tool as compared to some of these traditional CI/CD tool that that's available, for example, like the Jenkins. And the last of this principle of the cloud native CI/CD will be the DevOps principle, whereby this CI/CD should be cloud native should be built with the DevOps practice in mind, so that it allows a different team to own the delivery pipelines alongside the application without having to rely on the central center of excellence team that manage the delivery pipeline on the other team on behalf. Okay, this is a tables that highlight some of the different comparisons between the traditional CI/CD and the cloud native CI/CD. On traditional CI/CD, is mainly mostly is designed for the virtual machines, and it often comes with the centralized engine per se. And this centralized environment often require a specifically administrator or the IT ops member to maintain, such as performing the startup or shutdown of the server. you need also to install various kind of the plugin into the centralized server to cater for your multi CI/CD integrations point. And typically, traditional CI/CD is not designed for the Kubernetes, and thus there's less on actually no interoperability with the Kubernetes resources. Yeah, and one main thing is that on the configurations per se, and based on the traditional CI/CD, since it's a centralized, often all these configurations are embedded or centralized in the same server. Yeah, whereby for the cloud native CI/CD, it is really designed for the containers and the Kubernetes. Yeah, it's based on the distributed and the serverless mechanism. That's why there is no need of a centralized server or maintenance is required when we talk about cloud native CI/CD. Okay, each of the pipelines or CI/CD pipeline are fully isolated and no dependency with each other. So every execution is running in a container, and hence there will not be a scenario, say like in the traditional CI/CD tool, where when a CI/CD server is down, then all the pipeline cannot be executed. All the steps of your CI/CD pipeline, like doing the compilation testing, cannot be executed when the centralized server is down. So when we talk about cloud native CI/CD, also which is the characteristics of a serverless, is like there will be in total zero resources utilization if there's no pipeline running, because it is serverless and it's only spin the container on demand when you need to execute the pipeline, when you're starting with the pipeline. This is the time where the resources allocate to spin up the container to cater about the CI/CD pipeline. So since this cloud native CI/CD is since it's a cloud native CI/CD, it can allow the user to use all kind of Kubernetes resources, for example, like the Kubernetes persistence volume for the storage, or even the config map for the configurations in the distributed manner. So as compared to the traditional manner that we are talking about, you need to have your single place contain all the different configurations. But in the cloud native, you can have this cloud native leveraging on the Kubernetes resources. You can have the config map for distributed configuration for your CI/CD resources. Yeah. After all, it will allow me to sum the main difference between the traditional CI/CD and the cloud native CI/CD. I would say that one approach is more focusing on the centralized way of doing the CI/CD, and while the other will be the distributed way. We're talking about the different pipelines running on its own independence, with its own resources, way of doing the CI/CD. Okay, so that's the difference between the cloud native CI/CD and the traditional CI/CD. Okay, on this page, actually, when we come to talk about cloud native CI/CD, Tekton is one of the famous open source project or tool under the CD foundations, the continuous delivery foundations for creating a reusable CI/CD system or CI/CD process. So Tekton is Kubernetes native and is provide open source component to help the user to standardize their CI/CD tooling based on standard specifications around all these concepts like pipeline, release, workflow, build, test, deployment strategy, and so on and so forth. Yeah. Okay. Just for the audience info, Red Hat Openshift Partners is actually as a cloud native CI/CD solutions to build the CI/CD pipeline, and that is powered by the Tekton upstream project. Yeah. Later in our demo, we'll make use of this Openshift pipeline as part of a CI/CD tool to execute the CI/CD pipeline. Yeah. Okay. Let's just now we talk about the CI/CD. Let's talk a bit about the GitOps that actually complement the CI/CD process. So what is a GitOps here? Basically, GitOps is the developer-centric approach to continuous delivery, and even we are talking about the day two process like infrastructure operations. So when you hear about developer-centric approach, right, what you will be thinking of? You'll be thinking of like a source code, right? And how come developer-centric approach has to do with the GitOps operation? GitOps operations is exactly the concept of everything as a code. When we talk about everything as a code, we are talking about the entire state of our application, even the infrastructure and the configurations are defined declaratively and as a code. Okay, this includes how our infrastructure looks like, how the application should be deployed and how it should be configured across a different environment. So we are not talking about the source code repository only. Under the GitOps concept, actually, we're talking about the CI/CD infrastructure as a code as well, where the deployments need to be treated as a code and follow the same principle of the software development using a Git repository. And then the second thing is, under the GitOps, Git is the single source of truth always. Yeah, basically under this GitOps concept, the state of the infrastructure that I mentioned and the configuration and applications are to be stored and versioned in the Git versions control in order to take advantage of the traceability, visibility that provide the entire state of the infrastructure and applications. So under this concept, right, any changes that is available somewhere in the infrastructure or your applications must be represented in the Git repository first. So we have the Git mine as the our approach for the CI/CD with the Git. Okay, this is the GitOps application delivery model. In the application delivery model, we have two repositories. Actually, the first one is the application source report. We will use this application source report for our CI process to execute the CI/CD pipeline. For example, like fetching the fetch and compile source code, build the container and store it in the image registry, which can be used for deployment to any environment. So after this process, right, when the CI process of building the container image, basically the container image is a standalone deployable image that can deploy in every environment because it's come with all its dependence, library and all this for executable. So it's somehow it's an independent image that you can deploy in every environment. That's the stage for the CI part. And under the GitOps concept delivery model, right, we should have another config or deployment report, which is mainly for the infra. We will use it for the CD process. As mentioned, the CD is like talking about the delivery process to a different target environment. And we will use this report for our CD process to release the image to a different environment, like the stage environment or the pre-production environment. So for our demo today, for CI part, we'll make use of OpenShift pipeline, which is the enterprise support versions of the Tecton under the Red Hat. And for the CD part, actually we'll make use of our OpenShift GitOps, basically, which is based on the ArgoCD upstream project. Okay, let's talk about a bit on the ArgoCD. ArgoCD basically is implemented as a Kubernetes controller, which continuously monitor and running the applications and to compare its current state with the desired state that you define in the Git repository, on the deployment Git repository. So when it detects the drift, it will take the actions and synchronize into your deployment environment with the latest changes. The ArgoCD process is a continuous one that you will go back to the monitor and keep an eye of your any deployment or changes and do the necessary delivery steps. So the strategy of the GitOps that we're talking about using ArgoCD is to have a Git repository, which this Git repository is come with all our defined Kubernetes object definitions. It's a mechanisms to create and control all this declarative in the final system, which is our Kubernetes of a container platform. Okay. So that's basically about the theory part of what is the CI/CD, Cloudnative CICD, the tool, and let's come to the demo sessions so that we can understand from the tool itself how these things work and to accomplish the CI/CD process. So in this demo flow that we are going to show you guys today is the first developer will be working. Normally, the developer will be working on the coding and committed the Git's applications, the commit to the application's Git report. Yeah, once committed, in our demo scenario, we will show you guys how this commit will trigger the Tecton pipeline using the webhook with the webhook. Okay, once the Tecton pipeline is triggered, the Tecton actually will be executed and run the CI/CD pipeline, like fetch the code from the repo, do the packaging, and build the image and deploy into the environment, So in this demo, once this code change is done, the tech talk will be executed and run this CI/CD pipeline I mentioned: fetch, packaging, build, and then deploy. In this demo, we deploy into my first environment, which is a SIT environment. Okay, all these are done with the Tecton pipeline itself, from the fetch, the report, fetch, build, and then also the delivery until the SIT environment. All this within the SIT, within the Tecton pipeline. So after this is deployed to the SIT environment, okay, it will push the image into the image repository. In this case, we actually have our Red Hat Query as the image report that keep the image for subsequent deployment to other environment. And the last step is, for under the Tecton pipeline, the last step is actually what it does is update the deployment Git repo with the latest deployment configuration, which this latest configurations is about the latest image, right? Because we have done all the CI/CD step, right? Doing the fetch, doing the build, and then you build the image. And this image actually this image information of the configuration will update to the another repo, which is this deployment repo, the second Git. And once this is updated, the changes, our query, our ArgoCD will be detected these changes and pull this latest image from query and deploy into the UAT environment. So this is what we are going to achieve in the demo environment. And next, the last part is we will deploy our changes into the production environment. But some difference that we want to make in this demo is that for the deployment to the UAT environment, we will make use of the auto deployment approach. But for the productions, we'll make use of the we'll incorporate the manual approval. So once it's approved, this change will be proceed to the productions environment. So let's start with the demo. Okay, let me share the my. For these demo purposes, actually, we have to prepare a tree environment, as mentioned, the SIT environment, and we have and the UAT environment and a production environment. For different environment, we have configured different pods. For the first environment that we have is the SIT environment, we configure one pod, and the second environment, we have configured 2 pods to cater for the SIT or the UAT usage. And the final environment, we have the productions. Let's say we have 3 pods to cater production workloads that to handle this application workload. Yeah. So on your right, on the right hand side, right, you will see that a difference of the pods that we are trying to get access to the application. The first on the top actually is trying to do a curl to applications that we are going to demo today, and get out the message and then the pod name. So from here, you can see that it's only one single pod here, because in our first environment, we have only one single pod. For the second environment, we have configured with the 2 pods. And from here, you can see that the pod name is coming from a difference. There's a difference 2 pods name here. That's basically for the 2 pods, yeah. And then for the final environment, there will be a 3 pods showing the 3 pods message, as you can see. So let's go to our codes here. So on our demo scenario, we have this demo on the code change. Say that the developer, today you have applications and developer want to do some changes. And let's say that this is a code that we have code change for the demo purpose here, or we have pre-printed the good day here. That says there is a changes of application per se. Let me change this file as if you are changing your applications. And let's change good day from IO Foundation. And as soon as the developer making the changes or commit the changes to the report, right? But normally, mostly the developer will have their own local environment and doing the check-in codes to the report. But I'm doing this on the our first application report directly. So we make a changes of the message that good day from the good day everyone to the good day from IO Foundations here. Okay, so on the first, once we have this application change, let's go and check. This is the pipeline, OpenShift pipeline that I mentioned here. And we can see that once the code has been committed to the repo, and the CI/CD pipeline, it will be triggered and starting with the executions of the step that we just like we show in the steps, like different steps, like doing the compilations of the code and etc. Okay. Okay, the code, the pipeline has been triggered, and if you see from this pipeline detail, right, basically it contains all the steps like fetching from the repo. Basically, once it's trying to cat out the repo, whereby we have the applications, this application that doing a message printing of good day plus the host name. Okay, you try to fetch from the repo, and then once you get from the repo, basically it do a compilations of this code, and actually these are Java applications that is based on the Quarkus runtime. It's trying to do compilations, and then once it's compiled the codes, the next CI/CD pipeline step you are going to trigger is the building the image, the container image, and then we will deploy this container image to the SIT environment, which is what you see on the top screen, this window, the SIT environment. Okay, but then the next step is where we want to use the CI/CD. We want to make use of the ArgoCD to do the delivery to our UAT and the production environment. Okay, therefore, after deploying the SIT within the same Tecton pipeline, actually we are copying the image to the our repository, and then we will trigger the GitOps, updating the GitOps updating the repository of the GitOps. So here I have two repositories here. One repository is for the applications where just now we have this project that is printing the good day informations message with the host name, and we have another repo here which is the deploy for the GitOps usage. So on this pipeline, what it does is when the container is ready through our CI/CD process, it will copy this container image to our repository, and also next is to update the GitOps, which is to update this repository. So under this repository, actually we configure with the ArgoCD that listening to this repository, and when this repository or the second repository on the deployment has been updated, ArgoCD will take the process to the CD process to deliver to our UAT environment and the production environment. Okay. So it takes a time to build the image. Once build the image, then you will proceed. Then we can see some of the message change based on what we have defined. Yeah. And during expansions like Cloudnative's CICD, right, we are talking about the distributions and the resources on the container pod, right? Let's check on this one of these tasks, right, that is inside our CICD pipeline. If you go by checking the tasks, right, eventually all these tasks that is we are built inside the CICD pipeline is an individual pod, as you can see. It's spin out a different pods that cater for the these particular steps of the task. And once this task is finished, then it will be completed and release the resources back to the container here. So you can see just now we have a step like fetch a repo, package, build it, deploy it, and then we have the next steps. The deployment to the SID has been completed, and the next step is trying to do is copy the image to the query so that can be used for subsequent environment throughout the CD approach. Okay, and you can see that every time when the step is executed, basically it spawn a pod that is a container that is running particular for the purpose. Yeah. So the step deployment to the SID is completed. Let's check whether our SIT environment has been updated with the changes. Yeah. So on this top window, we have the good day from IO Foundations, where the code change on the from the repository has been if successfully packaged, deployed, and deployed to the SIT environment. Through this pipeline, yeah, the pipeline is completed on triggering the GitOps as well, so we can come and check whether this GitOps, this ArgoCD has been is triggered. Okay. Here we can see the UAT environment is configured with the manual. It's configured with the automated. Let me check. Okay. From here, actually, we can using the ArgoCD, we can configure our approach to deployment. Either is using the automated approach or manual approach. For this purpose of this demo, actually, we have configured the UAT environment to be an automated deployment. So once the changes has been updated to the Git report by our CICD pipeline, eventually this will be triggered. But there are some interval between the commit and the trigger and how the ArgoCD detect the changes. So for the time sake, perhaps we just do a refresh and manually so-called let the ArgoCD detect the changes here. Yeah. So by right, it was doing the automatically detecting the changes, but due to the interval we set in the configurations, perhaps it will take some time for the automated to take place. So in interest of time, I just do a refresh. I'm not doing a manual sync to that environment, but I do a refresh so that it can detect the changes. And once I'm doing a refresh, actually it detected the environments, the report image has been changed, has been updated. The application, the deployment report has been updated with the new container image. Therefore, it will take this and deploy to our UAT environment. Yeah. Okay. So it's just doing the same. And from here, basically on the the ArgoCD, right? You can see some of this process that is running. And some of this event to understand how is the process of these deployments taking place and the log, etc. So from here, actually, we have configured in our report the deployment report with 2 pods. So it spin up 2 pods. It will spin up the 2 pods based on what we have declared in the Git report for our this environment. Yeah, I started to deploy to these 2 environments. So what you can see here is also like a different view of the pod information such as a memory and etc. And then for this deployment, actually for this deployment, yeah, it will trigger to the 2 pods here. So SIT is completed now. Okay, let's go and check back the our window of the UAT. Sorry, the UAT. So you see now it's been updated with a good day from the IO Foundations. But for the production environment, in fact, we have configured this environment with the manual sync. Therefore, we need to come here and do a manual sync so that this can be taken as an approval process before you are moving changes to the productions. Let me do a synchronizations here so that they will take the these changes to the deployment manually. Yeah. Okay. And as soon as you see like on this pod, right, when the deployment is happened, is basically done on the rolling approach. It will make sure because the 3 pods, make sure some of the pod is being bring down to deploy with a new code change, and then bring up another one by one. So you can see once we sync manually deploy approve the synchronizations, the third environment, which is our production environment, started to have the message change to the changes we've done on the gig. So the source code gig, yeah. Yep. So it started to have each of the pod updated with the changes already. You can see here. Now all the pods that we have, the 3 pods that we have, which is the 88, FD, MF has been updated with the latest changes already. So we can make a sync here. So we have the 3 pod, namely for the MF, FD, and the 88 here. So yeah, that's the whole demo we want to show today. We make use of 2 Git repository. One is the source code. When the source code change, we trigger the CI/CD pipeline to help us to do the CI/CD steps, yeah, like this mentioned. And then once this step is done, we are handed the whole subsequent process to our CD tool, ArgoCD, to make the deployment to the different environment based on what we have declared in our gigs for the deployment. Yeah, so that is the demo. So you can see a click of change or a commit of a code change eventually automated the whole process from clone the code, package the code, build the image until the deployment of the different environment, 3 environment here. Thanks. So that's the end of the demo. Yeah. Okay. Let me come back to the slide. So that's the demo flow for our showcase today. And if you guys are really interested to hands-on on this ArgoCD and Tecton, you can go to the learn.openshift.com under the /GitOps, and there will be a few scenario that is come with the handily with the console with the steps that you can try to experience how to use the ArgoCD and the Tecton for your CI/CD process. Yeah. And for those developer that would like to have their own environment, the sandbox of more things, because I think on this exercise, that's the guided exercise to have a difference, to have the experience, to experience a different tool. But this sandbox, eventually, if you go to the developer.redhat.com, you can get your own developer sandbox whereby you can have the own container development environments for trying with all these CI/CD tool or the platform services for your CI/CD case. Yeah. So that's all for my presentations. Yeah. Any questions? Yeah. Isaac? Yeah. So guys, feel free to have your questions if you have any questions. Yeah. Okay. So if there is no questions, here in the IO Foundation's platform, there is this launch features. If you guys want to have a chat or some of collaborations about the demo just now, or discuss further on the CI/CD through the Cloudnative CICD, feel free to go to this lounge and look for me at this table 7. Yeah. And thank you for your times today. Oh, okay. There is a question from Mr. Lee about can we extend the ArgoCD to automate further infra level automation? Mhm. Yes, definitely. ArgoCD is a tool that you can further having the infra level automations where you can have the where you have the toolings that is required for you to do so. Yes, yes. So Argo CD also come with all these day two drift changes. So as long as the changes to the environments, Argo CD will always check back with your source code, your deployed Git repo to see is this changes is really a match to the declarative that is defined on your Git repo, and will do kind of the maintenance automatically to revert back to the right uh, right configurations that you want to have for your target environment. Thanks. Okay.